Y prime.
That's all you got? Whatever. Okay, so Y prime. You sound like another version of Siri or something.
Voice.
Okay, let's rewrite the Y prime as dy over dx. Okay, now we'll put the dx on this side. It's kind of like you're multiplying both sides by dx. So now it's dy equals that. We have this term, actually this part of this term has the x, this part of this term has the y, and this part of the term has the dx. Okay, so we want to get rid of this guy. We want him to be on the other side with the y, so what would we do?
Divide it out.
Divide it. Okay, we'll divide both sides by y squared plus 1. That will get rid of the y squared plus 1 on the right side, so you only have x terms over there. When I divided the y, the dy by that, this is not how I usually write it. I don't usually write it like that. I usually write it like with the dy out in front, and then I have 1 over, so I pretend there's a 1. 1 divided by, well, there is a 1. I don't have to pretend. Dang it, that's not an x. It's supposed to be a y. Okay, so you made the same mistake. All right, so now what do you do next?
Integrate.
Integrate. So we're going to integrate both sides. Okay, the right side is the easy side, so why don't you guys try that one first? Okay, for the right side, you add 1 to the exponent. So you have 2, then you have to divide by that number. So we get x squared, and I like to put my plus c on the right side. On the other side, we have a lot more work to do because we have a function inside of a function. That function, y squared plus 1, is inside the function. I'm going to make that one equal u. Actually, wait a second. I just realized something. This right here should look familiar to you. There's another formula out there. If you do the antiderivative of this, it's going to be tangent. Tangent. That's your x squared, the y squared right there, or whatever squared, whatever you want. So this is just going to be tangent y. Oh, snap.
What?
Almost forgot the inverse symbol. Now, let's get the y alone because that's what's happening over here. We're getting the y's alone. Because right now it doesn't look like anybody over here. So let's get this y alone. How do I get rid of a tangent inverse? What do I have to do to both sides to get rid of a tangent inverse? You tangent both sides. They are opposite operations, and so they will cancel each other out. You'll be left with y. And we do the same thing to the other side, tangent. So we have tangent of x squared plus c, and I believe that's over there. There he is, letter B. Man, we rock. Another solution! Sorry, I had to. No, guys, I'm making the video. You're like, oh, what's going on? Okay, dy over dx. Oh, yeah, it is. Plus 4y equals 0. Now, the first thing we're going to do is I'm going to put that 4y to the other side because we've got to try to separate our variables. And the only way to separate the dy over dx is through multiplication. So I moved the 4y to the other side, so now it's negative, and I'm going to multiply both sides by dx. Or at least it's like I'm multiplying both sides by dx. And then I have a y chilling right here. Now, to get this y to be with that y, we're going to divide. And I'm not going to divide by negative 4y. I'm just going to divide by y because if I bring the negative 4y over to their side, that'll be 1 over negative 4y. And then if I integrate that, I'm going to need to use u substitution or some pretty good intuition as to what's going to happen. So anyways, it's just going to be easier if I divide both sides by y. And this is what I would get. I would get 1 over y dy equals negative 4x dx. And then the next thing I'm going to do is integrate. So I'm going to integrate both sides. On the left side, I get natural log of y, absolute values. Don't forget that. We need the absolute values just because we have a log here, and you can never have negatives inside of a log. And so we're putting absolute value bars to make sure we don't have one there. On the other side, we have a negative 4x, and then we have our plus c. That plus c is for both sides, but we only need to write it once. Next, I'm going to do a base e to both sides because my goal is to try to get y alone. Now, the next part is going to be kind of weird, so pay close attention. Okay, so we got e raised to the negative 4x plus c. Now, here's the goal. Like it says, which one of these can be a solution to this differential equation? This is a general solution. Okay, why is it called general? Because it has this c right here. Now we don't know what the c is, but we got to pretend like it is a number, but we don't know what to pretend, what number to pretend it to be. Anyways, whenever you have addition inside of an exponent, remember that you can split it up by writing the base twice. So you have negative 4x and then times e to the c. And then if I wanted to simplify it just a little bit more, I would write 1 over e to the 4x times e to the c. So what we're looking for is which of these could be gotten by what we have right here. Now e to the c, we don't know what that number is. It could be anything. All right, it could be any scalar, like a 5 or a 3. It doesn't matter. It doesn't matter what e to the c is, but it could be something. Is there anything over here that matches this guy? And when you look over at the solutions, this guy right here matches him. And you'll say, what the heck? No, it doesn't, because it has this 4 right here. Well, couldn't e to the c be 1/4? It could. We don't know. This could be a 1/4 right here. And if it was, then it would equal the same thing as c. So that's your answer.